Hello, this is Mr. Huff. Let's take a look at some information about air traffic control. So let's start by talking about pilots. Pilots fly under two kinds of flight rules. One is IFR, or Instrument Flight Rules, which is used by all commercial endeavors. It would be unusual to find a commercial flight system that did not use instrument flight rules. Then the other one is visual flight rules. We'll talk more about these in just a moment. But visual flight rules, and this is mostly non-commercial, like this would be private pilots and that sort of thing. And this is also referred to as general aviation, just people that fly. So usually they fly with visual flight rules. Okay, let's take a look at this. So in this cockpit, you can see, if you look out the cockpit window, this pilot can't see what's happening around him. We can tell by looking at the instrument panel that he is flying level and his altitude is about 4,000 feet, and he is using navigation and that sort of thing. But he has to depend on these instruments to tell him what's going on, because he can't use his eyes to see what's happening. And this is why instrument flight rules are important, and why commercial requires instrument flight rules. In the world of aviation, there is an idea called the 300-second rule. A pilot that is not trained in instrument flight rules, if they lose sight, like if they fly into a cloud, they have about 300 seconds to get out of that before they die. What happens is, when you don't know how to read the instruments, you're depending on all the cues from your sense of balance and your eyes to tell you what's going on, and you have no point of reference, and you make bad decisions, and you end up crashing the airplane. When flights first started in the olden days, it was all visual flight rules. There were very few instruments that were connected to the airplane, and you had to really understand the landscape around you, like you needed to understand where the cities are and what they look like from the air. And you could kind of just take off and land whenever and wherever you wanted. And it was just kind of everybody just goes wherever, they just hop in and fly. There weren't very many people flying. So as we started having more and more flights, and people started doing commercial flight, where it's at the start they were using seaplanes a lot, because you don't have to have a runway for an aircraft that can land on the water. It was uncontrolled. Everybody was just kind of taking off and landing and taking off and landing wherever. After World War II, we made a lot of advancements in aviation. We started seeing a lot more commercial flight, and then things like this would happen. This is some wreckage from a historic event where two commercial airliners ran into each other near the Grand Canyon, and everybody died. And that was what triggered the United States government to form the FAA and start air traffic control. Let's think about air traffic controllers. Their job is high stress, because literally people's lives depend on their decisions. These jobs, they make a lot of money. The physical requirements are extremely high. Pilots, they have to take physicals, and if they fail a physical, they can't fly. If an air traffic controller fails a physical, they can't be an air traffic controller anymore. The requirements for their physical fitness are very, very high. What they do, so this is a program or a web page called FlightAware, and you can see real time all the airplanes in the air at any point in the US at a given time. And if you click on one of those airplanes, you can see its actual flight and their planned flight, where they're leaving from, where they're heading to, and you can actually get down to the information about what kind of airplane it is, how long that flight should take. Lots of information. So really, air traffic controllers can only control two things: what direction the plane is going and how fast they fly. Those are the main decisions that they have, that they can use to keep all of the airplanes safe. When you're looking at maps like SkyVector and you see these purple regions around airports, so you can see we have a airport right here. There's a little town there in yellow. That's what it looks like at night. And then this purple zone around it. When you are in an airplane and you're in this purple zone, you are under control of this flight tower. They get to tell you what to do, how fast you can go, what direction you can fly. You have to do what they say. And it's to keep everyone safe. That's the reason. You can also see on this map, we see the blue line, the blue circle here, that's the VOR compass rose. And then this light blue line is a Victor airway. This is for low en route flights. So this is VOR navigation right here. It's like a highway in the sky. Let's talk about airspace classification. So Class A, which is this red band at the top, this is where jet routes are. This is the high en route flights. And there are also, just like with VOR, there are lanes, sky lanes in this zone where planes are expected to fly. So this is 18,000 feet above mean sea level. Note these acronyms down here. We have AGL, which means above ground level, which is the altitude from the ground, which is mean sea level minus the elevation of the ground. And then FL is your flight level where you're actually flying. Let's talk a little more about Class A and Class B. These two zones are controlled by air traffic control towers, and then everything else, it's two-way communication. In this case, Class B, notice the closer you get to the ground, the smaller this circle is, the higher up you go, the larger it is. So it's like an upside-down wedding cake. If your airplane is flying in these regions, you have to do what the tower says. Similar here, but these two are just two-way communication. They're not really doing air traffic control. They're just trying to make sure everybody knows what everybody else is doing, so there's not a collision. Let's talk about approach patterns. So the idea is that you enter flying with the wind. This is your downwind leg of the approach pattern. And then you turn across this way. This is your base. And then you make your final approach. Notice that you would be flying into the wind as you landed. This makes your landing speed lower because you're gaining velocity because of the movement of the wind. So the net velocity is increased because you're flying into the wind. And when you take off, you're flying into the wind, and that also gives you added velocity because you're flying into the wind. And then if you, for instance, right here, you're making your final approach and you figure out, okay, I'm going too fast, I can't land safely. So then you keep flying and then you go crosswind and make this box again. And you can repeatedly try to land by following this pattern. But the tower, and when you're flying at an airport under two-way communication, you're expected to follow this pattern, okay? Let's talk about Next Gen a little bit. So Next Gen is simply the Federal Aviation Administration's plans for the future. So we have, in this Next Gen page, you can go look at what they've done to get where they are today and the policies and systems we have in place currently to keep everybody flying safe. But we know that technology continues to advance and people continue to make laws and that sort of thing. So that's where you can look into the future a little bit and see what they're trying to deal with. So like one of the things that you will see here that wasn't there 10 years ago is now you have a section for drones. And that's something that we'll probably see more and more rules and regulations for, and technologies applied to keep everyone safe.